Today we are covering section 11.2, finding the area of circles, which we've done before, and the main focus of this section is finding the area of sectors. So to find the area of a circle, we can just take pi times the radius squared. Like I said, we've covered that section before, but just as a refresher there. Remember, if they ask you to leave an exact answer, leave pi in your answer, treat it like you would any other variable, and just simplify it around it. If they say round, go ahead, use 3.14, and you can get your rounded answer that way. A sector is part of the circle that's in between two radii and the arc that connects those two. So think of like a piece of pizza or a piece of pie. That would be a sector. So that's what we're finding the area of. Very similar to the last section where we looked at the proportion of the circle that the arc was taking up. Now we're going to look at the proportion of the circle that the sector is taking up. So we're going to start this problem very similarly. We're going to look at the central angle over 360 and set that equal to the sector over the total area. So looking at a few examples, we want to start off with this proportion pretty much for any problem where we're dealing with the area of a sector. We're going to find our central angle over 360, that's the part over the total, and set that equal to the area of the sector, which is the part over the total area, which is pi r squared. So in our first example here, we have a radius of 4. We have the arc measure of 135. That's the same as the central angle. And they're asking us to find this green shaded area, so that green sector there. So plugging in what we know that the central angle is 135 degrees over 360. I like to simplify that if possible. Those both divide by 45, so that simplifies down into 3 over 8. And then that's going to equal area of the sector, which is what they asked us to find. So I'll put x in for that. And then the total area of the circle is pi times the radius squared, pi times 4 squared. Careful, sometimes IXL likes to be tricky and give you the diameter, so make sure you cut that in half before you find the radius. Cleaning that fraction up, we would have x over 16 pi. Let's say leave it exact, so we want to leave pi in our problem and just work around it. So from here we can cross multiply. We would get 8 times x equals 3 times 16 and pi. Getting x by itself, then we can divide both sides by 8 to give us 6 pi. So the area of that sector would be 6 pi. In this next example, once again, they like to be tricky and they switch up. They give us the diameter, so make sure that when we are plugging that into our formula, we cut that in half for the radius. This time they want to know the angle measure. So they give us the area of the sector. Now we have to find the angle measure. We can still start with our same formula and just plug in what we know. So we don't know the central angle this time, so that's what we'll put the x in for. Still over 360 equals the area of the sector, which they do give us this time, which is 8 pi. And then area of the circle would be pi times the radius, which is 8. Remember the diameter is 16. Cut that in half to find the radius, squared. Again, cleaning up anything we can. Not much we can do with the first fraction, x over 360. Second fraction has a pi in the top and bottom, so those pi's could cancel out. That would give me 8 over 64. 8 over 64 reduces down into 1 over 8. Cross multiplying, we would get 360 is equal to 8x. And then divide by 8. To get 45. So that angle would be 45 degrees. In the next example, we know our central angle is 100 degrees. We know the area of the sector. This time they ask us to find the area of the total circle. So once again, go back to your formula, fill in what you know. We know the central angle, 100 degrees, always over 360, equals the area of the sector, which they did give me this time, which was 17.46. And then they asked me to find the area of the circle, which is this entire bottom pi r squared. So I'm just going to put an x in for that. This one we can go ahead and cross multiply. We get 100x is equal to 360 times 17.46. Which would give us 6,285.6. Dividing that by 100 would give me 62.856. And for the last example, they want us to find the radius, so we'll leave r in our problem, and they should have given us all the other information there. So the central angle we can see is 78 degrees. Now that central angle applies to this unshaded area, but they gave us the area of the shaded region. So we just need to subtract that from 360 and use 282 as our central angle. Once again, the 78 applied to the unshaded region. We needed the central angle for the shaded region. Over 360 equals area of the sector, which is 20.89. We are trying to find the radius this time, so we'll put pi r squared in the bottom, and r should be our only variable, which it is, so that means we should be able to solve for it. So go ahead and cross multiply. That would give me 282 pi r squared. That would equal 360 times 20.89, which is 7,520.4. Divide both sides by 282. And then the directions on this one did say to round, so we're going to divide both sides by pi as well, so divide by 3.14. And that would leave us with r squared is equal to 8.4930 ... Last step to get r by itself then is to take the square root of that number. And if we round it to the nearest hundredth, that would be 2.91. Once again, get r by itself and take the square root to get rid of the squared. Hope that helps. As always, as you're working, please don't hesitate to ask questions, send an email, reach out through Flipgrid, whatever way is easier for you. But ask questions, ask questions, ask questions.